Hello everyone, I'm Adam. In this problem, what we want to do is use de Moivre's theorem to find the power of a complex number, which we have here, 1 plus I to the fifth, and then write that in standard form. So first, let's take a look and kind of review our de Moivre's theorem. So what that says is if we have a complex number z, which can be written in trigonometric form, right, r times cosine theta plus I times sine theta, and we have some positive integer n, then the power z to the n, which is taking our trigonometric form raised to the nth power, can be computed as r to the n times the quantity cosine of n times theta plus I times sine of n times theta. So to make use of that, well, we're going to take our complex number here, take z as our 1 plus I, and our power, right, n is equal to 5. So to make use of our formula, what we need to do is necessarily find the quantities of r and theta so we can plug them in over here. So first, r, which is our modulus of z, which is going to be the square root of, say, a squared plus b squared, where if we consider z in our form a plus bi, so r is going to be equal to the square root of, looking at this, 1 squared plus 1 squared, or giving us, say, the square root of 2. So we have r. Now we want to find theta, and with theta, we can make use of the equation, say, tangent of theta is equal to, say, b over a, which is 1 over 1, or equal to 1. Now, to solve for theta, first we're going to pay attention to where our z is located at, particularly which quadrant. So if we kind of graph z really quickly, consider our real axis here and our imaginary axis here. So with our a and our b, 1 unit in the real direction and 1 unit in our imaginary direction. So we get z, 1 plus I, and the angle made from the real axis, put that in, right, say theta, here is in the first quadrant. So what that tells us is with our tangent theta equal to 1, we can just solve theta is equal to, say, arctangent of 1, which arctangent of 1 gives us pi over 4. And we could have gotten that just by looking at the picture anyway. If we look at theta, essentially our going out 1 unit and up 1 unit, we have the sides of a right triangle with length 1 would just be 45-degree triangle, which would be pi over 4 anyway, but this is okay. So now we have r, we have theta, and then we're ready to use our equation here in de Moivre's theorem. So our z to the fifth, or 1 plus I to the fifth, right, is going to be equal to r to the n, or square root of 2 to the fifth, times our quantity, right, cosine of n times theta, or 5 times pi over 4, plus I times sine of n times theta, or sine of 5 times pi over 4. Okay. Now we're just going to simplify this a little bit. So square root of 2 to the fifth, we can simplify that as, say, 4 times the square root of 2, and times the quantity cosine of 5 pi over 4 is a negative root 2 over 2, and sine of 5 pi over 4 is also a negative root 2 over 2. So we're going to have, say, negative root 2 over 2, say, I. And we're going to continue to write this in our standard form, so we're going to multiply through with our constant here. All right, so if we distribute our 4 times the square root of 2 in here, well, we see that the square root of 2 times square root of 2 will just give us 2 on top. And so we'll actually have 2 over 2 for both of these terms, and those will cancel, and all we'll be left with is just a 4. So in the end, we're going to have the constant negative 4, and then minus 4i. And that's equal to our z to the fifth, or 1 plus I to the fifth. Thank you very much.